In this video, we'll be going through A-Level Maths Pure 1, Chapter 1. Do you know that 60% of the Pure 1 content you learn in Year 12 is actually from GCSE? Only 40% of the content will be new from GCSE. That is, basically new stuff that you haven't seen before. Now, it is a very nice introduction to A-Level content, in my opinion. If you've done GCSE Third Maths, you will find some of the content, some of the 40% new content might be from old stuff as well, so even less. There is an empty PDF version of the notes that you see on the board in here, on the screen in here. If you would like it, it's in the description below. I would highly recommend you to print them out or even download them and follow it as you watch the video. So let's dive in. In Chapter 1 and 2, I grouped them together because mainly they're just algebra stuff. Especially Chapter 1 is all about GCSE algebra recap, so setting you the foundation of what you need to know for the A-Level algebra content. Right, without further ado, let's dive in. So, index law, the good thing about video is if you feel like you know them, you can just, skip them. And you can pause the video and have a go whenever you want, etc. So, a to the power of m times a to the power of n is, we know, is a to the power of m plus n. Divide, subtract the power for power, we multiply it. And then when we have a bracket and then to the power of n, because they're multiplied together, so we can apply the power of n into both of them. One silly mistake students make is that they put a to the power of m plus b to the power of n. We know that doesn't work. Alright, so make sure you don't make that silly mistake. Example, simplify this. So power for power means a to the power of 10 times 3a squared. Okay, we're going to keep the integrity of the expression. That means, yes, we have done something to this term in here in the first term. However, in the second term, we'll also keep it in there. Because what it means is step by step, we're not losing the traction. We're not losing the trace of the expression. That means if you want to go back in every step, you can see there's a connection to it. People can see what has been done, what hasn't been. For example, if you look at this step compared to the expression and this one, we can clearly tell we've done something to this term because times 3a squared remains the same. Now we can simplify, obviously, 3a to the power of 12, and that's the final answer. This one, 3 squared is 9, x cubed squared, 3 times 2 is 6, 4 times 2 is 8. Okay, so we don't square these power, we multiply power. Right, pause the video, have a go at practice question 1. When you're ready for the answer, you can press play. Well, here are the final answers for practice question 1. Easy peasy, lemon squeezy. Right, next one. Experiment brackets. If you were ever taught about a FOIL method, if you don't know what it means, I think it's front, outside, inside, last. We don't need this method, cleanse it from your mind. Essentially, what we'll do is we'll multiply each term in the first bracket by each term in the second. If you don't know what I'm talking about, ignore it, completely. Just multiply brackets like how you normally do. So, example in here, the first one, we're going to expand the double bracket in front. So, x squared, 2x, and we can sort of do a step ahead, times plus 1x is plus 3x, plus 2. Now, I've expanded these two brackets, so I'm going to put a bracket around it and then copy the x plus 3. As I said, it's important that you keep trace of what you haven't done. So make sure from line to line it is still valid. So you can't just suddenly disappear ignore the x plus 3. You have to put it in there even though you haven't done anything yet. Now then we can multiply in. So we can expand the brackets. So x squared. Oops. So x squared and x squared and 3, 3x and x, 3x and 3, 2 and x, 2 and 3. Right. So x squared times x cubed, x squared, 3x squared, plus 3x squared, plus 9x, plus 2x, plus 6. We can collect the like terms. 3x squared, 6x squared, 9x, 2x, 11x, plus 6. Easy. Do the same for that one. We expand the bracket here first. X times 5x is 5x squared minus 3xy. Put a bracket around it, and then we copy the last term out. Since we haven't done anything about that, now we can expand the bracket. Okay, 5x squared times 2x, 10x cubed. 5x squared minus 3y. Make sure you do it carefully. 15x squared y. 5x squared times 4 is 20x squared minus 3xy times 2x minus 6x squared y. Minus 3xy times minus 3y is positive 9xy squared. Minus 3xy times 4 is negative 12xy. Look carefully, see if I collect any like terms. Yes, I can. This and this is like terms. So 10x cubed minus 15 minus 6 minus 21x squared y plus 20x squared plus 9xy squared minus 12xy. Right? So, yeah, practice question 2. Pause the video. Your turn. Have a go. When you're ready for the answer, you can press play. Here are the answers for practice question 2. Expand double bracket. Make sure when you cube the negative bracket, make sure you be careful with the negative sign, and that's all really. Right, next, fractional and negative indices. When you have a power of 1 over something, it means you're mth rooting the value. So e.g., if you have a to the power of a half, means you square root a. You can put a 2 in here, but we normally don't, so square root of a. Or with power of 1/3, means cube root of a. A to the power of 1/4 means 4th root of a, etc. You get the idea. When you have a power of n over m, it means you can write both ways. You can either mth roots of a, because we can see again is 1 over m again, and then power of n, or you can do a to the power of n first, and then mth root it. Both way works. So e.g., for example, if you, let's say you have a to the power of 3 over 2, that means you're square rooting 8 and then cubed it, or you can write as 8 cubed and then square root it. Alright, now this will become quite useful, because even though if you don't know A-level maths, we can always use a calculator, a more powerful calculator than the GCSE one. Not every time the calculator can compute this efficiently, so sometimes you do have to work it out yourself. So even though we can rely on the calculator in most of the cases, sometimes we can't. With a negative power, hopefully you know, negative power means you put it 1 over. Okay, so e.g., if you have a to the power of minus 3, then that's the same as 1 over a to the power of 3. Or let's say if you have 2 to the power of minus 4, it means 1 over 2 to the power of 4, which is the same as 1 over 16. Yep, last one, a to the power of 0. Anything to the power of 0 is 1. We know that. Alright, example below, simplify the following expressions. X cubed over x to the power of minus 3 means we subtract the power. Negative means x to the power of 6. This one, power of a power, means we multiply it. 3 times 2 over 3, same as just 2 squared. Next one, 125 x to the power of 6 to the power of 1/3. To the power of 1/3 means you're cube rooting 125, and then for the algebra, you multiply the power. So cube root of 125 is 5. Hopefully you do know that. 6 times a third is 2, so 5x squared. Next one, 1/9 x to the power of 6, y to the power of a half. A half means, to the power of a half means square root. So square root of 1/9. Okay, and then for the algebra, you simply just multiply the power. That's the power of 1. 1 times a half is a half. Square root of 1/9 is 1/3. 6 times a half is to the power of 3. And y to the power of a half. Yep. Okay. Carry on. Practice question 3. Have a go at a question. Okay, practice question 3. When you're ready for the answer, you can press play. Well, here are the final answers for practice question 3. 3 times 2 is 6. X to the power of 4 plus 0.5 is 4.5. Or you can write as a fraction. Sometimes we can write as a fraction. Sometimes we can write a decimal. We usually write as a fraction. Next one, to simplify this, we can write a square root as a half, power of a half, cube root as power of 1/3, and then we can add the power together and give us 5 or 6. Here's a challenge question. Okay, so given 2 to the power of x times 4 to the power of y equals 1 over 2 root 2. So you can use the whole equation. Express y as a function of x. You want to make y the subject, so y equals something. Pause the video, have a go. If you want to get some hint, here it is, okay? Or if you don't want to listen to the hint, you can pause the video and just carry on, just blast it through. The hint is you want to make everything as 2 to the power of something. Okay, so your ultimate goal before to get the final answer is to get 2 to the power of something equals 2 to the power of something. Okay, Pause the video, have a go. When you're ready for the answer, you can press play. So that's the final answer. Y equals minus 3/4 minus a half x, or y equals minus 3 minus 2x all over 4. So anything equivalent will be fine. So the way to work it out is, okay, if you got it right, well done, move on. But if you don't, let's see why. So, by the way, this is a past exam question in A-level maths. That's why if you find it a bit difficult, it would make sense. Okay, so 2 to the power of x, so we can't do anything about that, so we're going to rewrite that. 4 to the power of y, we want to write 4 as power of 2, so 2 to the power of 2. And then with power of y, so 2 to the power of 2y. Equals 1 over 2, can't do anything. Root 2, what's root 2? Root 2 is 2 to the power of a half. So then, from here, on the left hand side, we can just add the power together. X plus 2y equals 1 over. We can do the same with that one. It's 2 to the power of 1 plus a half. That's the same as 2 to the power of 3 over 2, or 1.5. And then, we don't like the 1 over. The 1 over means a negative power. So now both sides has base 2, so we can now make the power equal to each other. Then from here, it's just basic algebra to make y the subject. So first of all, we can minus x on to the right side, divide by the 2, so minus 3 over 4 minus 1 over 2x. Or you can write x over 2, so or x over 2, that's the same thing. Alright? Next. Quadratic equations. You should be very familiar with quadratic equations. You've done a lot of them in GCSE. So we know quadratic equations means the highest power of x is squared. Quadratic equations can have 1, 2, or no real solutions. You get used to it. You will see them a lot later on. So there are 3 ways you can deal with a quadratic equation. You can either factorize them, you can either complete a square, or you can do the quadratic formula. To factorize it, that means we'll put in bracket, okay, into factor form. It's useful, okay, when we need the factors. Okay, so useful when we need the factors. In GCSE, you would have factorized a lot, but in A-level maths, you don't, because you will have a very powerful calculator that can help you to solve any quadratic equations. Alright, yes, it is, that's right. Completing a square. Completing a square means you could put in the format of x plus a squared plus b. So when is it useful? It's useful when finding the turning point. So hopefully if you remember the parabola of a quadratic, the shape of the quadratic curve is called parabola. If you want to find the minimum point or the maximum point, you can complete the square to work it out. Or useful for equation of circle. Now you learn this chapter 6, equation of circle. Right? So quadratic formula. Well, when is it useful? It's useful when you, well, let's recall the quadratic formula. Minus b plus and minus b squared minus 4ac all over 2a. Truth is, you don't have to remember this formula anymore because, again, you have a calculator. So when is it useful? It's useful for finding roots. You are going to rely on quadratic formula a lot, essentially a calculator for working out any quadratics. You don't get any method mark for showing how to factorize, how to use quadratic formula. Unlike GCSE, you don't get any marks for that. They expect you to use a calculator, 10 seconds, boom, you got an answer. Right? So, example, solve the following equations in here. Now, I assume you don't have a calculator right at this point because usually you get a calculator in the first 2 to 3 weeks. By the time you're watching this video, most likely you're not going to have a calculator with you. So I'm going to do it without a calculator. But I'm going to show you with a calculator what it looks like. So example, solve the equation here. So we can bring everything on one side to make it, we know we have to make one side equal 0 to solve a quadratic. And then here we can factorize it. If we factorize it, we get x minus 5, x plus 3 equals 0. So x minus 5 equals 0, or x plus 3 equals 0. So x equals 5, or x equals minus 3. Right? Oops. Now, part B. I would like you to pause the video first, have a go at part B, see what answers have we got for part B. Alright, when you're ready, you can press play. So for part B, I assume a lot of students would have done this. Okay, if you haven't seen this before, A lot of you would have done this. Cancel the x, so then you get x equals 9 as the final answer. However, this is wrong because you're missing out one answer. I'll show you how. Now, if I bring the 9x to the left-hand side, like any other quadratic, I'm going to bring one side equals 0. Okay, then in here, I'm going to factorize the x. Okay, factorize the x. Then treat this like a bracket. So 2 brackets multiplied by 0, like the previous one. Then each of them equals 0. So what's different? Difference is, if you do it that way, you would have ignored x equal, you would have omitted x equals 0 answer. And that is very important. You can't miss it, because when you draw the graph, essentially these two numbers are called the roots where we cross the x-axis, right? Or the x-intercept, some people may call it, but roots. Therefore, you can't afford to miss any answers in here. If you do that in exam, you actually lose marks, right? So if you're happy with this, okay, have a go practice question 4, and whenever you're ready for the answer, you can press play. By the way, whichever method you want to use, you can use quadratic formula, you can use anything that you like. All right, pause video. When you're ready, press play. Here are the answers for question A, B, and C. X equals 1, x equals 3, x equals minus 6 or 7. Doesn't matter how you get there, you should get these answers. Part C, I've shown you the steps. Bring the 9x to the left hand side, as I said, like the previous part B in the example, and then factorize. You can either factorize x or 3x, then 3x equals 0, or 2x minus 3 equals 0, so x equals 3 over 2, the two answers. Now, this is one of the calculator, might be a lot of you would be guessing, or the other one, which is CG50, the powerful graphical calculator. Either way, either calculators have this function here. So if you go on menu, and then if you go in here, equation function, and then the first one is solving simultaneous equation, which we're not interested right now, so we'll do polynomial. Degree, we know power is 2. So then in here, we can do, let's say for the first one, we can do 1, and then we'll have to put in the coefficients, so minus 4 and 3. Press equal. x1 equals 3, so we get an answer, x1 equals 3. The other one is 1. Okay, let's try one more, for example. We can also find a minimum point, by the way, using calculator. So let's say we'll do C. 6x squared minus 9x plus 0. So one of the answer, x equals 3 over 2, and the other one 0. So in A-level maths, what happens is, when you see this question, the next line is you can jump into here straight away. You don't have to show any of them in between, any steps in between. Right. Next one. So complete a square. Oops, forgot to clean it from last time. So we're going to do complete square. So complete square for the following expressions. To complete a square, hopefully you do remember, means we have to do bracket x and half that coefficient of the b term. So 8 is 4, so half of 8 is 4 squared, and then minus 4 squared, which is 16. Alright, if you expand a bracket, by the way, if you expand a bracket, you should get the question expression if you do correctly. So just to double check with you, so just to show you what I mean by that. So I'm going to expand double bracket, so x squared for 8x plus 16, and then minus the 16, they cancel out. You can see this is the same as the original question. Right, so that's how we complete square. Part B. To complete square for this one with the coefficient in front of x squared, we first have to factorize it out. So 2 and then x squared minus 6x. Next, we can do the complete square in here. Now, bear in mind that anything we do complete square in here is within the square bracket. So we do have to put a square bracket before we do complete square. So in here, complete square means half that minus 6 is minus 3. And then subtract that 3 squared, which is 9. And then we have to expand the bracket, put the 2 back in. So 2 times x minus 3 squared minus 9. 2 times minus 9 is minus 18. Right. By the way, what is the minimum? What's the coordinates of a turning point in here? The coordinate is opposite of this one, which is minus 3 becomes positive 3, and this one, keep it as it is, minus 18. Right. Not really relevant in here, but just to show you. Part C. What about part C? Part C with a minus in front. That's a similar case in part B. Similar case to Part B, where we have a coefficient that is not 1 in the front. Well, why is it not 1? Well, this minus 1. So technically, they're not the same. It's like Pepsi and Coke. They're not the same. Part C. So what we're doing here is we do factorize the negative out. So it's like factorizing negative 1. So give you x squared plus 14x. What about the plus 20? We put it outside because the plus 20 has nothing to do with the completing square. For the completing square, we only care about the a term and the b term. The constant term, we can just leave it outside. Okay, just like waiting outside bus stop. Next, we complete a square, put a minus there, and then complete square. So half that 14 is 7 squared. And then you minus 7 squared, which is 49, and then plus 20. Put the minus back in again, so minus x plus 7 squared, minus makes a plus, and then plus 20. That gives us minus x plus 7 squared plus 69. And that's the final answer. Right, so pause video, have a go. Practice question 5. When you're ready for the answer, you can press play. Here are the answers. Question A, half that 16, which is 8 squared, and then minus 8 squared minus 64. Part B, you factorize the negative 2 out, so that gives you a negative 6 inside the bracket. And then you do complete square in here carefully and slowly, then you will get your final answer. Multiply minus 2 back in, give you plus 18, so 18 plus 7 is 25. And that's the end of the algebra recap.